This is the day 2 of linear inequalities. Today our focus was looking at graphs and seeing if we could write the linear inequality that would represent that graph. So, if you look at the graph, we attacked this the same way that we did whenever we were writing linear equations, and that is we looked for the pieces of slope-intercept form. So the first thing that I would identify whenever I'm looking at a graph is I would look at that y-intercept. So notice this graph is touching the y-axis right here at -2. That's going to give us our b value. So remember, in slope-intercept form, it's y equals mx plus b, and that b value is your y-intercept. So once you identify that, that gives you your -2. We know that something is being multiplied by x, and that something is m. That's our slope. So remember, your slope is the ratio of rise over run. So on this graph, notice the line is sloping down, which tells me that my slope is going to be negative. Then, starting from my y-intercept, I notice that I have to go down 1 and over 2 to get back onto my graph, which makes my slope 1 over 2. Remember, your slope is always your rise to your run. So on this one, I went down 1, that was the negative part, and to the right 2. That was your denominator, your +2. So we have y. Now this is a linear inequality. I can tell because I have this shaded portion. Remember, the shaded region of this graph and any ordered pair that falls on the line represents a solution to the inequality. So notice that this line is solid. If it's solid, remember, you're going to use the less than or equal to or greater than or equal to. So I know this symbol has the equal to part. Now I need to determine, is it greater than or less than? So if you put your pencil on your y-intercept and you point where the shading is, it will help you determine if it's greater or less. Since this line is shaded above the y-intercept, that would be greater than or equal to for your symbol. That means that this inequality, y is greater than or equal to -½ x minus 2, would represent the graph that they've given me here. Okay, so I took quite a bit of time to explain that first example. I'm going to go through the same explanation for this one, but a little bit quicker. So if you notice here, once again, I'm going to start with my y-intercept, which happens to be at +1. I know that I'm going to have x, and I need to figure out my slope. Once again, my line is sloping down, so that makes my slope negative. So my slope here, I would look at, and I notice that if I start on 1, I actually have to go down 1, 2, 3, and over 1 to get back on my graph. So if I start on the y-intercept, I go down 3 over 1. That makes my slope -3 over 1, which is the same thing as -3. I have my y, and now let's look at our symbol. So notice that this graph is dashed. When it is dashed, you're going to use greater or less. Remember, the dashed line tells you that the ordered pairs that fall on the line are not part of your solution set. It's only the ones that fall in the shaded region. So I know this is not going to have an equal to, it's just going to be greater or less. But I'm going to use the same method. I'm going to put my pencil on my y-intercept and I'm going to point where the shading is. This is shaded below the y-intercept. That would be less than. So y is less than -3x plus 1 would represent this inequality. For this inequality, notice that we are first looking at a vertical line. So we've spent a lot of time talking about vertical and horizontal lines, and I'm going to use the acronym that I always use. When I see a vertical line, I think VUX. That means that vertical lines have undefined slope and they are x equals. So that tells me that this is going to be x for my inequality, not y. So what does x equal? Well, I notice that the x-axis right here, where the line is going through, is at -1. So x and we have -1. Now I'm going to look at my symbol. I notice this is a solid line. Remember, solid lines are less than or equal to or greater than or equal to. Now on this one, it's a little bit different because we don't have a y-intercept. But if I put my pencil on my x-intercept and I point where the shading is, it's to the right. So I know that this is greater than or equal. The inequality that represents the graph that's shown here is x is greater than or equal to -1. For this last example, I chose a horizontal line. Remember, our acronym there is HOI. Remember, HOI stands for horizontal lines have 0 slope, and they are y equals a number. So I have y. Where does this touch the y-axis? I notice, 1, 2, 3, it's touching right here at 4. This is a dashed line, so I know my symbol is going to be less or greater. Remember, the dashed line tells me that the ordered pairs that are on the line are not part of the solution. The solution falls only in the shaded region. So I am going to put my pencil on the y-axis, on the y-intercept. I'm going to point at where the shading is. It is below the line, which is less than. That means that the inequality that represents this graph is y is less than 4. Okay, this takes care of day 2 of our linear inequalities. So we started with writing and graphing linear inequalities, and we will be moving forward to systems of linear inequalities coming up very soon. So if you are struggling with linear inequalities, just the basic ones where it's one line, you need to make sure that you come in for tutoring so that we can get you on track. You guys have a great day.